This video will show you how to run the engineering component for CFS trusses in Vertex BD. It will use a simple gable roof with a couple of trusses, which have already been generated using the generates part method. It is important to note that this newest method of adding in the truss structure should be used and not the old and incompatible truss structures method. Now we need to add in the truss connections if they weren't already added when the parts are generated. These are a series of connection details that are necessary to fix the trusses to each other and to walls. These connections are vital in successfully running the engineering and are accessed via the connection details command, which is found in the engineering tab. Go to the trusses directory to see all of the available truss connections. Double-click the one that is to be added and then select the trusses. Now select the wall panels and confirm. If applicable, define the parameters and click OK. The connections will then be added. Once done, the truss part numbers need generating, as the engineering requires each member to have an ID for it to be able to run. It is a requirement that a ceiling or horizontal structure is directly below the bottom chord of the roof truss, as this is used for generating some of the loads for calculating the engineering results. With these steps complete, the actual engineering can now be run. First, go to the engineering menu and select Define Building Internal Pressure Area. The internal pressure area will automatically be defined as shown in the pop-up. However, it is possible to manually define this by clicking the relevant option. This area will then be shown as a dashed red line. Furthermore, it is essential that all the loads for the ceiling structure be calculated before the same loads are calculated for the trusses. Next, the windows need calculating. Again, go to the Engineering tab and select the Windows command. If the ceiling layers are currently packed, then a prompt will appear. Now select the ceiling to add the windows to and confirm. The system will then ask to define the main wind direction. This can be set via the left and right arrow keys on your keyboard. Once this step is confirmed, the Design Criteria window will appear. For the design code, certain aspects will be grayed out dependent on the region. However, reliability and service classes can be defined. For the wind loads themselves, these can be manually or automatically defined based on supplied information. For this example, the settings will be left as is. The wind loads would then be calculated. You then need to repeat this step for the roof. With the roof wind loads generated, the next step is the member and trusses analysis function. This allows you to set different live, dead, and snow loads and set buckling rules. Once they are defined, click OK and select the truss envelopes, confirming afterwards. The program will then run through the trusses, calculating all of the loads. Any errors or warnings will appear in the messages window. Clicking a message will display where the error is. These usually highlight if a member fails, in which case a thicker gauge of steel could be used to rectify or some reinforcement added, ensuring member design is rerun after any changes are made. As of 2018, it is possible to open up a single truss and make changes. To do this, with no active command, hold Alt and select a truss. Now right-click and go to Truss Engineering. You can then see the problematic profiles and joints, adjusting where necessary, then rerunning the engineering on that particular truss using the Solve command. The final step is to produce the engineering outputs and drawings. This is done via the Truss Results command. First choose the truss envelopes and confirm. Then choose the drawing type. The results will build and can be accessed via the project document browser. The engineering drawings contain a wealth of information, displaying if the design passes or fails, along with the calculation results, connection results, reactions, and any errors if applicable. One other thing to note is in 2D, if a truss passes, the truss label will be green. If it fails, it will be red. More in-depth information can be found from the Member Results command in the Engineering tab. This function has all of the collected information about each piece. However, this example only has information regarding the truss pieces, and a different way to access the warnings and errors. Generally, the piece information will include the profile label, its type, and a brief summary of the loads involved. Full calculations can then be accessed by selecting the relevant piece and clicking the Detailed Output button. Similarly, stress indices can be accessed the same way. This concludes the video on Truss Engineering. Please see the Vertex documentation for further information about Truss Engineering. Thank you for watching.